Hey guys, we're going to take a look at these absolute value transformations and what their effect will be on some graphs. Not critically important for the overall understanding of this stuff, but certainly a good exercise in understanding how functions work and how they act on numbers and what orders things happen, all that kind of fun stuff. So for the function I've chosen, this graph here on the left at the bottom is f of x. I can tell you the one I put in the calculator to come up with that image was x squared minus 3x minus 4. You know, that factors to x minus 4, x plus 1, and you can tell the zeros of that would be 4 and negative 1. So you can see got an x-intercept at negative 1 and another one over here at 4. Pretty straightforward. I intentionally chose one that was not symmetric with respect to the y-axis so that we could see what happens for the positive x values and for the negative x values as we go each way. So the first one up that we're going to look at is what would the graph of the absolute value of f of x look like? And if we remember, f of x is kind of like your y values. And we remember what absolute value does, we should be able to figure out what a picture of this thing would look like. Because again, what we'd be doing is taking the absolute value of all of our y values. So for example, if we had a table of values, x and f of x over here, and for example, the fact that 4 gets you 0, for example, the x value of 4 gets you 0. That's what that would look like. If we were to absolute value that, it would still be 0 because the absolute value of the 0 is still 0. But for example, 5, if you plug in 5 for an x value, if we plug in 5 here, we'd get 5 minus 4, which is 1, and 5 plus 1, which is 6. So we get 1 times 6, so we get 6. And we'd absolute value 6 and get 6. So you can see nothing's really changing. The absolute value of these numbers of 0 is still 0. The absolute value of 6 is 6. But of course you know that about absolute value. Absolute value doesn't do anything to positive numbers. It makes it interesting when your result is a negative number. So if we put in something like x equals 2, at x equals 2, we've got this y value down here. That y value will be 2 minus 4 multiplied by 2 plus 1, which is negative 2 times 3, which is negative 6. So now we'd be taking the negative 6 and absolute value in that and getting a y value of 6. So that point down here is going to get transformed to positive 6. So I've taken the liberty of dropping the graph in here, and so we can take a look at what the original graph looks like, which was shown here in blue, and we can try to create what this function's graph is going to look like. And I think based on what we just did, I did f of 4 and that didn't change. I think I did f of 5 and that's y value was 6, so that's not changing. So in fact, all these y values up here are not going to change. And I think you'd agree that for these positive y values over here on the left, they're not going to change. But what happens is any y values that were negative, that is these guys down here, those guys are all going to become their opposites. That is, when we got a y value of negative 6, once we absolute value it, it becomes positive 6. So for example, that 2, negative 6 in the transformation graph is going to become 2, positive 6. So that means we're going to have a point up here at 2, 6. So that point got transformed and came up here. And likewise, all these points down here are going to get transformed and up to their opposites. So what's going to happen is we're going to have all these points getting flipped or reflected across the x-axis. And we're going to get this thing to come something like that. Okay guys, so what I've done now is I've imported the graph with both the original x squared minus 3x minus 4 in blue and the graph of the absolute value of that in red. And you can see the red graph just laid right over top of the blue for all the parts of the blue graph where it was positive, and then you can see all the negative y values got reflected above the x-axis, came up here like that. So this extra thick red line is the graph of the absolute value of f of x in this case. Now I use this quadratic just because it was easy to model with, but this would be true for any function that has that you're looking at the absolute value of that function. What I mean by that is I've just kind of shown another function here, and we can call this blue guy f of x. And if we were to look at a red guy, which would be the absolute value of f of x, how would that differ? Well, for the portions above the x-axis, the graph would remain unchanged because those are all positive y values, and absolute value doesn't do anything to positive y values. It just keeps them the same. So these guys are all going to be the same. However, the portions that are underneath the x-axis, all this stuff down here and this stuff over here, that stuff is going to get reflected, and it's going to become the opposite. The y values are going to become their opposite. So you get something like a Humpty thing coming up here, and then another thing like that. So portions that were above the x-axis are unchanged. Anything that's below the x-axis gets reflected above the x-axis. And that's what the absolute value of f of x will always look like. Okay, guys, for this next transformation, we are looking at f of the absolute value of x, not the absolute value of f of x. Two very different things. I'm just going to, rewrite that for emphasis. That the absolute value of f of x is not the same thing as f of the absolute value of x. This is what we did in the first example, and we took all the y values, and if they were positive, they remained positive. However, anything that was negative, we took the opposite and made it positive. This function, f of the opposite of x, is going to take the numbers that go in, for example, 3, and absolute value that number, not changing it because it's 3, and then applying the rule of f to that, effing that. However, if a number like -2 goes in there, the first thing that's going to happen is it's going to get absolute valued and become a positive 2, and then it's going to apply the rule of f to 2, and f2 and going to get the same thing that 2 always got, which was a y value of -6. So it's going to have serious repercussions on any negative numbers that we plug into this function. Aren't going to get treated like they're negative numbers that they are. They're going to get treated like they're positive counterparts. So if we kind of walk through this process and take a look at what happens to -3, for example, if we plug it into this function. First thing that happens to -3 is it's going to get absolute value of -3. So then we'd be squaring that, and then subtracting 3 times 3, and then subtracting 4, and we'd get 9 minus 9 minus 4. And we're going to get, like I said, -4. So when we plug in -3, we're getting a y value of -4. So I'm going to go ahead and put a dot there at -4. And you might recognize that, hey, that's the same y value we had when x was positive 3. And of course it is, because even though we plugged in -3, because it got absolute valued, it got treated like a positive 3. So -3, the first thing happened, it turned into a 3, and then we f'd 3 and got a -4. So there's our y value, and of course our ordered pair to match it over here on the graph. Now let's plug in -2. -2, the first thing that happens is it's going to get absolute valued and then squared, so it's going to become 4. Then we're going to do 3 times the absolute value of -2, and then subtract 4. So that's going to be 4 minus 6, which is -2, minus 4, which is -6. So -2 is going to get us, initially become absolute value and become a 2, and then get us a y value of -6. Once again, look at -2, and we're going to get a y value of -6. Exactly the same y value we got when x was positive 2. So I'll go ahead and put a -6 in there at -2 for an x value of -2, and we'll move on and do another one. When x is -1, the first thing that happens is it becomes positive 1 when it gets absolute valued, and then when we f1, we also get a y value of -6, because you can see it on the graph here. When we f1, we get -6. So -1 gets first treated like, gets turned into positive 1, and we get a y value of -6. Now 0 is going to be a little bit interesting, because 0 is the absolute value. It just goes to 0. And we already know that f of 0 is -4. So that point is not going to be changed. starting to see what's happening. This parabola that we had on the right side over here is kind of now just getting repeated on the left side. And you might want to just check our x-intercept there. When x is negative 4, I could do one more point down here at the bottom. When x is negative 4, you can see the first thing that's going to happen to that, it's going to become 4 and then get treated like positive 4 did, and positive 4 gets you a 0. So that, kind of showing the trend. Whatever's on the right side over here is just going to get repeated on the left side. But again, for these positive x values that go in, and for example the 0, when they get absolute value, nothing happens to them. They just, 1 stays 1, 2 stays 2, 4 stays 4. So their graph is going to be completely unchanged. F of 1, it used to be negative 6, it's still going to be negative 6. And we get this point right here. F of 2, the absolute value of 2 is 2, so we plug in 2 and we get negative 6, same as we always did, negative 6. So we're getting these points on our graph. F of 4, absolute value of 4 is 4, plug in 4, we get 0. So we get that point, and you can see this graph's going to kind of look like that. So let's check and see if we're correct. So now you can see that I've dropped the image in there, and you can definitely see our guesses were correct. And if we wanted to try to kind of describe this absolute value of f of the absolute value of x, again, very different than the absolute value of f of x. If we want to describe that, we could say whatever's on the right side of the y-axis is going to remain unchanged because absolute value doesn't do anything to positive x values. However, the left half of the graph, that blue line, notice that just got obliterated. We don't get any of those values that way. What happens is, because we never get to see negative 1 really get treated like negative 1. Negative 1 gets treated like positive 1. Positive 1 gets us negative 6, so negative 1 is going to get us negative 6, and so forth. Negative 2 is going to get us the same thing that 2 did. So negative 2 gets us negative 6, and so forth. So this portion of the graph just gets obliterated, and you wind up getting sort of a mirror image to what's on the right on the left. So now it would be kind of cool. Let's take a coordinate plane here that I just drew in here, and maybe we can make up some phony function and see what it's some phony function for f of x, and then see what f of the absolute value of x would look like. Okay, so here's a graph. This blue guy is, I'll say, the graph of f of x. And if I wanted to find out what f of the absolute value of x would look like, we can just do what we did in the last problem. Realize that everything that's on the right side of the y-axis, so that's all this stuff, is going to be completely unchanged. Okay, so if I were to graph that in red, we would just go like this, and that stuff is going to be completely unchanged. Now, what happens to the stuff over here on the left is it's just going to get obliterated. And it's not that there's not going to be anything there. It's just, it's not going to look like this stuff over here on the left side. What's going to happen is this piece on the right is going to just get repeated or reflected over on the left side. So we can go ahead and say, all right, let's just kind of mirror this stuff across the y-axis and then maybe come down here and finish off like that. So this red stuff that we can see, and maybe I'll go real thick on it, would be our final answer for what f of the f of the absolute value of x would look like. Okay, so now lastly we have our case of we're going to do the absolute value of f of the absolute value of x. So this shouldn't be too bad because we've already created this function on the last slide, f of the absolute value of x. So for example, we'd be looking at something that would just repeat this right side. Oh, I think I want to do that in red. We just repeat this stuff that's over here is going to be unchanged. Remembering that this stuff as we know it is just going to get obliterated, and we're going to mirror what's on the left over here, or what's on the right over here on the left. So that's the black function, what I have shown here in black, f of the absolute value of x. Now, our final answer, though, is the absolute value of that red graph that we just did, f of the absolute value of x. So we got to think about what would absolute valuing the y values of this look like. Well, we saw that before. when you have absolute value on the outside, you're basically talking about taking this stuff here and everything that's underneath the x-axis, and that stuff is just going to get reflected above the x-axis. So I guess I'll try to draw my final guy. Maybe I'll just go in, maybe I'll try this lime green color here. So I'm going to make this graph in lime green. It's going to be the absolute value of f of the absolute value of x. And I'll use lime green. I'm just going to go pretty thick here so we can really see what we're going to look like. This stuff unchanged. This stuff unchanged because we have positive y values there. But all this stuff underneath the x-axis, all that stuff, that is going to get reflected back above the x-axis. So we're just going to go, let's say this point down here is going to get flipped up there. So something like that and that. So that light green graph that you see up there is the absolute value of f of the absolute value of x. So hopefully that helps you. Probably have something like that on our upcoming test on this stuff, but hopefully that'll be a good case for why we did what we did.